Hello, everyone. Welcome to the session. Thanks for joining. I am Sawada. Today, I am going to talk a little bit about the ruby.wasm thing. In my case, I am talking about the edge computing side of the thing, which using the WASI interface. So let's get started. So quick introduction. So okay, I'm spending maybe half of this session for maybe terminal demo, so that I will moving my screen from this keynote in terminal and back and forth. So first, let me go to the terminal. So my introduction. I am Kei. I am Rubyist since 2011, and what I'm going to show first is that just as an introduce myself, my favorite gem. Okay, so let's get started. Which is Ruby gems. So this is the Ruby gem that I created 10 years ago. And at the RubyKaigi 2014, I gave a presentation about this Ruby gem before one time. And this is my second time to give a talk at RubyKaigi. And this is the interesting Ruby gem because this can give you some interesting game development framework. Okay, say, I don't know. Let's see. Because I was working for a gaming company, I created this for my side project. Okay, so just using this simple DSL, and then run this command, and then this is actually the Nintendo ROM file, which is the NES binary file. So the idea is that we can create the NES file, which can be loaded and used for the optocarrot optimization, which I think Mame-san started his project since then. And I'm really honored to be here again. So just, yeah, as my quick introduction. And this is nothing related with the WebAssembly, sorry, but again, Yuta Saito, I think he created interesting project using optocarrot because he made it work on the WebAssembly environment already. So that this means that you can create your NES ROM and you can load it into that optocarrot, which is working on the WebAssembly, so which is great. Okay, so let's get started. So this is me. Just I'm such a kind of hobby Rubyist here. And going back to the slide. So now I am working for Fast3, which is the CDN company, and I am working as a compute strategist. So my main job is that helping people make their life easier using the edge computing network. Mostly using the Go, Rust, or JavaScript are the main languages that Fast3 now supported. And the Ruby is currently it's an unofficial language. And I am working on as a side project, using my private time. So with those assumptions and the introductions, let's get started about the WebAssembly session here. So WASI, because the WASI is, I'm assuming you guys are not too much familiar with the WebAssembly world. Maybe you saw, some of you or many of you already saw that Yuta Saito's talk or Kondo-san's talk yesterday about WebAssembly. And WebAssembly, there are two types of WebAssembly. One is the working in the browser, which is the WASM. And the other is the WebAssembly, which is working outside of browser, which we call it WASI. So in a nutshell, on the left side, it's the browser version. So WebAssembly can run anywhere, literally. So WebAssembly can run within the browser. But on the right side, you can see that now, thanks to the WASI interface, WASI is the interface, the specification. And thanks to that specification, WASI can run outside of the browser, which is the left side. And I'm talking on the left side thing, okay? So yesterday, maybe you guys saw the Mastodon, the demo that Yuta presented. That is on the left side, browser side thing, but I am going to talk about how we can use the WebAssembly outside of the browser. And okay, demo of the WASI here. But maybe because of the interest of the time, maybe I need to skip this, and there are more demos going forward, so that let me keep talking about these slides. So my talk title is Turning CDN Edge into a RAC web server, right? So let me first define what is a CDN Edge. CDN Edge, are you familiar with that? I'm not sure. So when you first hear the CDN Edge, maybe you might sound like it is kind of maybe the platform which we can download the static content, right? In fact, for example, can you read this character? Can you read it? Okay, good, okay. So gem install bubbles. So actually, for example, here, okay, if we download the gem, we always communicate with the rubygems.org, right? And rubygems.org is hosted in this IP address, which is hosted in, I think, the fastly here. Okay, good. So yeah, usually this is the CDN, how CDN works, okay? So RubyGems is a static file, right? And how you interact with the CDN edge network is just downloading the static content from those network. So that's the basic idea of how CDN edge work. But with the WASI support, actually you can run your program running on those CDN network, which means that CDN has usually the many POPs all over the world. Like in Fastly's case, they have about 100 POPs all over the world. And you can create and run your program, arbitrary program, deploy your program onto these 100 POPs, and then run it. So that is the basic idea of how you can use the edge network for your programming. And then currently Fastly again supports the Rust and JavaScript and Go, and Ruby is kind of in development mode as an open source unofficial SDK. Okay, good. So 2 years ago, Yuta Saito gave a keynote at RubyKaigi, I remember. And back then, he already created the initial version of a program when he gave a keynote entitled Ruby meets WebAssembly. And maybe some of you remember this UI, right? So this is actually the working on the server side. WebAssembly program is working. This is not browser side, okay? So remember that at the beginning of the session, I talked about the left side and right side. This is the right side of the thing. So on the server side, WebAssembly program is working. That's what the Yuta Saito already did 2 years ago. And I thought this is really interesting demo, and at the same time, I feel like there is something more we can do. So that is the basic idea and how I started my project. And my idea is like, what if we can run a RAC web server on the edge networking? Wouldn't that be great? And maybe many of or all of you are familiar with RAC, right? RAC is a web server interface. And there are many web frameworks and web servers. Most popular is maybe Rails, but other frameworks like Sinatra or the Padrino or other frameworks are available. And also on the server side, there are many popular servers like Puma or Unicorn, or those kind of stuff. And then I was wondering if could that be maybe we could add a fastly compute as a web server, and that would be maybe great if we could migrate our RAC application to the edge compute network without any hassle. And that is the basic idea of what I wanted to do. And I mean, more likely, I wanted to see what happens. And I want to share what happened actually. So this is the setup that I really hosted since 2015, I think. This is just one tiny VPS instance running on some VPS network. And I set up Nginx server and Unicore. There's no crazy stuff here. It's just a ordinary setup, right? And I have at the bottom right here, Sinatra app, you can see, right? So I created some Sinatra app for my blog application. So that is just a setup. Maybe some of you are also running some similar setup for your Ruby application. This is the commands that I use to run my blog application. And this is the blog history, that Git history. Then the idea is again, that making this red box, turning this red box into the CDN edge. Then, so the first, is it feasible? And if it's feasible, how does it look like? Then this is the status that the Yuta Saito already created 2 years ago. Again, the simple web interface. Then he created some simple script called demo.ruby, and which called some host call functions of the edge network side. And so that is how that WASM application is working. I'll be touching on more deeply later about this architecture, but just the overview of the architecture is like this. And yeah, demo.ruby is kind of simple script, right? Just maybe 20 lines of code. And at the top of the script, you can see some require statement, and also followed by the instantiate the body class and the response class, and just writing some response and return to the browser side. So that is how Yuta Saito created his script for his presentation. This is just a dump version of the WASM file. No time to talk deeply about. But what I wanted to make it happen is that this architecture. So notice that there is the difference from this diagram. So one box is added in the middle of the gray box there. So I wanted to run my RAC application, and then I need some adapter in between the WASM implementation host call and the RAC application. Then I need something that behave like a RAC server side. And if I could create that thing, then I thought I could make my RAC application work on the CDN edge network. So that's the basic idea. So I wanted to run my RAC application without any change, basically. But actually, it turns out that I needed to change something, but later I'll touch on that. So the first I started to work on the Lobster. Lobster is a kind of reference implementation, maybe, of the RAC application. So this is the most basic stuff that one can consider. So, and if we click this one, yeah. So this is the Lobster working on the edge network. And if you click here, so it flips, meaning that this implementation is working on the edge networking. I'm not sure which pop is the nearest from here, but the server firstly maintaining is processing this request and making the response to this browser. Okay, the response, okay, the Lobster is working. And then get back to the slide. I want to talk how I made it happen. So yeah, there was something I needed to do in addition to what Yuta Saito did 2 years ago. So, okay, reviewing this code at the top. So yeah, there are two classes are initialized, but there are other things that I needed to add, like the request header manipulation or the request body manipulation, handling, and then response status code, editing, or those kind of stuff. So I needed to add a bunch of the host codes first. And then there are host code definitions available that firstly published to the world. And so I needed to, I ended up writing some Ruby C extension here in C, and those function stuff, and this is the amount of the code. Just not that many, right? Just not crazy. Just write some glue code here. So that finally I made it work. I could now get the successfully get some HTTP header by coding the host code, and also I could edit some set header, and also here the status code as well. So yeah, the first thing that I needed to do is that I needed to add some host codes implementation. I mean the glue code to code those host codes. So then moving on to my blog application, was it successful? Like the no change migration was successful? No, I needed to change something. So this is the initialization code of my blog application. And this is the gem file. But it turns out that, for example, C extension was not available. Although the Yuta Saito mentioned that yesterday, the C extension is soon to be available. But back then, I mean, I tried this last year. And when I tried this, C extension is not supported. So that I needed to look for the Markdown library, in this case, which is written in the pure Ruby code, which was a Cramdown in my case. And then next, there was some constant missing error here, which was really just quick. I just added the one line of code into the gem file. Then the last is that I needed to modify the file path there. I used the relative path here, but that was not working out of the box. So I needed to specify adjust the path name here. And with those modifications, I made it work. So yeah, this is the blog application. Notice that the static content is not bundled into the WASM binary because of the size limitation issue. So that I didn't include those, but the basic stuff are working. So that's how it works. So yeah. And then other than that, so Sinatra application somehow works. And what about other rack application? For example, T-Diary, maybe it could be working. Actually, the build was successful, but when I tried to boot it, there was a runtime error, which is saying, like, for example, mkdir error, blah, 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 was okay, blah, blah, blah. So those are mkdir, for example, is not supported in the ruby.wasm because the WASI VFS is the read-only file system. So you can't create or you can write operation to the file system, right? So that is one limitation that I noticed. The other thing in the Rails, there was a build error, which is something about the big decimal in Rails case, but maybe I heard that this big decimal issue can be resolved by some tweaking or modification, something, but I didn't go into further more than that, but there was a build error issue. So it doesn't run out of the box. There was other rack application, like this is Rhino or Rhino, just works, so that was good. So TLDR, some rack application can work out of the box on the ruby.wasm, some doesn't. So that's the conclusion here. So what worked? Okay, so my Sinatra rack application works, yeah, with some modification like this. So there was a challenges, and this is the conclusion of my session because I only have 5 more minutes. The first one is the static files were too big as I expected initially. Like imagine that blog application should have a imagery, like the pictures or the CSS, JavaScript, but maybe imagery. The pictures are the biggest binary, but if the WASM file size is getting too big, like more than 100 megabyte, then I cannot upload those to the Fastly network. So that was one limitation I needed to think about. Also, the limited number of the frameworks that works out of the box. Lastly, the performance issue that I wanted to touch on here, the size and the performance. There are a few applications that is working on the Fastly edge network application, edge network. And file size has maybe not that different. You can see from 35 to 38 megabit. Those are the sizes basically. So that's another issue. And also the heap memory, that's a more or less same. Sinatra consumes more memory than others. Understandable, like that is relatively bigger application and amount of the code. The biggest challenge here was actually the response time here, and you can notice that on the right side, some application, especially Sinatra, takes too much time. Like to get the top page, it takes more than 1 second by average. Yeah, Lobster and Roda, those are also consuming some amount of time. And let's get back to the terminal. This 200 or 300, is that such big number or not? And to show you about that, here, okay, so maybe I should, okay, this is the, okay, root localhost. Maybe this is the VPS somewhere, I think in the US. And if I hit the Sinatra application, you can see it takes 1 second by average. But so this is I think the challenge. If I switch it to the official supported language for Fastly, Go, it's quite fast. You can see that the 58 milliseconds, what does this website do is quite simple. It just returns the hello world, and if there is some path name here, then that is returning another string here. So just a really quick example here, but you can see the latency is the sub 100 milliseconds, right? Like this is the 80 milliseconds or 63, like quite fast. So compared with those other languages, I have to say that ruby.wasm currently has some challenge in the performance, and maybe partially because the asyncify thing, based on the conversation with Yuta Saito I had yesterday and 2 days ago, and there is a challenge. And my conclusion here, maybe we need to wrap up this session, but my conclusion here is that there is a challenge in the performance, but at the same time, I see huge opportunity here that ruby.wasm what ruby.wasm can do outside the browser. And if you are curious, then just start looking at the ruby.wasm GitHub repository. Then maybe there should be some interesting findings in, I don't know, the performance or whatever, the aspect of the ruby.wasm. So, and then go talk to the Yuta Saito or other folks. And I think RubyKaigi is the best opportunity to do that. So that is all from me. Thank you so much for coming. And yeah, I just agree with Yuta Saito. Yesterday he mentioned that let's make the ruby.wasm more fun and interesting. And I really agree with that. So let's make it happen. Thank you so much.